Okay, factoring polynomials, the sum or difference of cubes. So we have these two formulas. When we have a cubed plus b cubed, so the sum of two cubes, it can be factored out to be a plus b times a squared minus ab plus b squared. When we have the difference of cubes, a cubed minus b cubed, it can be written as a minus b, a squared plus b, ab plus b squared. So let's do a few examples. Example number 1, we have x cubed plus 27 cubed, 27. First, we want to make sure that 27 is a perfect cube. So we take the cube root of 27, which equals 3. Okay, and the cube root of x equals x. This gives us our a and our b. Now, all we have to do is plug in x and 3 into this formula right here. Again, x is our a, because that is the cube root of x squared cubed. So we have x plus 3 is our b, because 27 cubed is b, so we plug it in to where we see b. Okay, and then we continue on. Okay, and then we just simplify everything, make sure it's all good. And voila, that's what we do. Okay, let's do the same thing over here. Let's solve for our a. To solve for our a, let's take the cube root of the first one. So the cube root of x cubed is x. So that is our a. And then let's take the cube root of 8, which gives us 2. That will be our b. Again, we have the subtraction of, now we have the subtraction of two perfect cubes, so we're going to use this formula, subtraction. We get x minus 2, x squared plus 2x plus 2 squared. And then I'm going to simplify this. And there we go. Here's our two answers for these two examples. Now what we're going to do is we're going to go to ones that are a little bit more difficult. As you can see, we have now a number outside of our x cubed. So we have a leading coefficient now that's higher than 1. So what we want to do is we want to take the cube root of that, 8x cubed, which gives us the cube root of 8 is 2. The cube root of x cubed is x. That is our a. Then we want to do the cube root of 64, which gives us 4. And that is our b. So we have the sum of two perfect cubes. So we want to follow this formula way up here. So we have 2x plus 4, 2x squared minus 2x times 4 plus 4 squared. Okay? So this part right here, we can't simplify that anymore, so we leave that 2x plus 4, bring that down. The 2x is being squared, so 2 squared is 4, and then x squared, because we have to bring in the 2 into both the coefficient and the variable. Now let's multiply that through, we get 8x, and 4 squared is 16. And there we go, that's our factoring. As you can see, we can actually factor out a number. So this is not the complete factorization. This is just following the formula. If we want the complete factorization, we need to take out a 2 right here out of this one, which would give us 2, x plus 2 by dividing each term by 2. And this one, we would have to divide each term by 4. That would give us x squared minus 2x plus 4. Now, since we have two coefficients kind of brought out, we multiply these together because they're all getting multiplied each other. So 2 times 4 is 8. And this would be the complete factorization of this. Okay, we have one last one. Example. Again, what we want to do is we want to take the cube root of this. So 27x cubed, take the cube root of that, and we get 3x. Okay, this is our A. Take the cube root of 125, which gives us 5. That will be our B. So we have the difference of two cubes. So we're going to be following this formula right here. So we have 3x minus 5 times 3x squared plus 3x times 5 plus 5 squared. Now we want to simplify that. 3 squared is 9. 15x plus 25. Looking at this, there's nothing we can pull out. We can't simplify it anymore. So that is our complete factorization. Okay. And that is how you factor the sum or difference of perfect cubes.